One of the most important roles of the AGT is the testing of the atmosphere within a confined space prior to the entry of personnel. Confined spaces can contain flammable gases and toxic gases, and the oxygen levels may be depleted or they may be elevated. All of these conditions present a hazard, both to the AGT and those who need to work within the confined space. Therefore, it is essential to plan the test to ensure that the risks are reduced to a LARP, and the test provides a representative sample of the overall atmosphere in the confined space. It is important to take samples at the top, middle and bottom of the space to locate varying concentrations of any gases and vapors that may be present. Remember, highly concentrated levels of gas can accumulate at the top or bottom of the space depending on whether they are more or less dense than air. Diluted gases and vapors will distribute themselves evenly throughout the space. It is especially important to sample the air at a distance from the opening to the confined space, as air intrusion near the entrance can give a false sense of adequate oxygen present. As part of the planning process, you should consider the size and complexity of the space to be tested. For example, large storage tanks may not be possible to test from the manway only. Entering the space to continue testing would then require you to wear breathing apparatus. In turn, this would require entry via the Permit to Work system, which would include a risk assessment and a rescue plan being developed before issue of the confined space entry permit. Complex configuration of vessels with compartments, weirs and baffles will also require careful planning in order to obtain a representative sample of the internal atmosphere. You should also consider the inventory that was within the confined space, the method of cleaning and flushing that has been used, and if any purging has taken place. The more information obtained prior to testing allows a more detailed test plan to be implemented. On this process plant, there are many vessels that have complex configurations with baffle plates, weirs, demisters, bubble cap trays, distribution headers, and liquid boots. In these cases, taking gas samples from the manway alone will not allow a representative sample to be taken. Therefore, as part of the planning process, the AGT should consider taking samples from various points within the space. This may require the gas detector to be lowered on a rope to check areas that are not easily accessible. Gas detectors that can log events are ideal for this type of testing, as they show results at various sample points. Complex vessels may also have layers of stratified gases which are buoyant in air, have not been fully purged, and may not be accessible for testing from the manway alone. Entering a complex confined space in breathing apparatus to carry out testing of the atmosphere is not ideal, but it may be the only way to ensure a representative sample can be obtained. This type of entry should be a last resort, and if necessary, will be controlled through the confined space entry procedures that your company has in place. Some confined spaces that are to be tested may be tall vessels, such as distillation columns or de-aerator columns. Normally these columns will have been cleaned and flushed, and all of the manways may be open to the atmosphere to allow air movement. As the AGT, you need to be aware of the chimney effect that tall columns can create. Natural air movement from the bottom of the column opening to the top manway causes a jet stream of air. Testing from the bottom or midway manway in these circumstances can lead to spurious test results, as the air passing past the probe will not be a representative sample of the atmosphere. In this situation, all air movement must be removed, and the top and midway manways should be covered to stop the flow of air. Representative samples can now be made at various levels of the static atmosphere. The following tests can now be carried out in sequence. Test to ensure that proper oxygen levels are present and that the atmosphere is neither oxygen deficient or enriched. Test to ensure that no combustible or flammable gases are present, and then finally, test to ensure that there are no toxic gases present. Before any testing of the atmosphere within the confined space, takes place, it is good practice to make a visual inspection first. This is particularly important when carrying out atmospheric testing of process vessels. Using a torch or inspection light, carry out a visual examination of the internal of the space, but do not lean into the vessel or put your head through the manway. Remember, there may be toxic gases or nitrogen purge gases in the vessel. What happens next? What are you looking for? Type in your answer and then select Submit. Firstly, do a check on the cleanliness of the interior. Has the vessel been flushed and purged? Any residual sand or debris can contain entrapped hydrocarbons or H2S, which may be released when personnel start work in the confined space. If the interior is not clean, pass this information back to operations, requesting that further flushing and purging takes place prior to testing. What should you be looking for? Type in your answer and then select Submit. You can learn a lot from the visual condition of the vessel. For example, a coating of rust indicates that a chemical process has been taking place and ferrous oxide or rust has formed. During this process, oxygen is depleted as it combines with the iron in the steel. Therefore, you may expect lower oxygen levels when you test. If there is a cluster or dimple pattern on the interior of the vessel, this shows that microbes have been present, and this could give an indication that H2S may be present. Always carry out a visual inspection to provide some information up front of what you are likely to encounter. The risks of testing confined spaces must be taken seriously. Toxic gases, such as H2S, can be fatal in a very short time. Depleted oxygen levels can cause drowsiness and poor decision-making. Increased oxygen levels can have an intoxicating effect on the human body. The AGT exposed to this may react in a drunken-type state and may carry out dangerous actions. High oxygen levels can also impregnate clothing, making it highly flammable. So although you are testing the atmosphere to protect others, your own safety must always come first.